You're going to go ahead and learn the law of sines and law of cosines. These are used to solve non-right triangles if you're given three pieces of information. Now you can't solve every single triangle given a certain amount of information. So we will go over what you can use. So actually we'll start with that right now. For the law of sines, you can use the law of sines if you know angle, side, angle of a triangle. So two angles in the included side, or angle, angle, side. So two angles in a non-included side. Or in some cases, side, side, angle. And this, there's actually it's called the ambiguous case or a special case. We have to check those specifically, and we're not going to get into that in geometry here. Once we get to the law of cosines, you'll be able to use the law of cosines if you know all three sides, or if you know two sides and an included angle. And we'll get to that later. But if you know all three angles, you can't find the three missing sides because they could just be similar, but it has to do with similar triangles. So law of sines can be used if you know two angles and an included side, or two angles and a non-included side. So let's state the law of sines. We're not going to go through the proof right now. We're just going to state it and use it in a couple examples. So there's actually two forms of the law of sines. So you can have side A over sine of angle A. And obviously these are just variables. You can use different ones. But in that same triangle, if you have another side B, the ratio of A over sine A will equal the ratio of B over sine B, and in fact, it will equal the ratio of C, side C, over the sine of angle C. Now, we don't use all three of these ratios at once. We might like set up an equation with these two, or maybe we would set up an equation with these two, or we could set up an equation with these two. But what will end up happening is you'll know 3 out of the 4 variables there, and you'll be able to find the missing one. We would use this form of the law of sines if we're looking for a side. If we're looking for a side, because the sides are in the numerator. If we are looking for an angle, we can just flip everything, and we can use sine of A, angle A, over side A equals the sine of angle B over side B, which is also equal to the sine of angle C over side C. So what we will do here is work through a couple examples, and I'll leave a couple for you guys to do on your own. So in this first problem here, notice that we are given two angles and the included side. Two angles and then the included side. So that's in the form of angle, angle, side, so we can use the law of sines. So what we do first, so this says solve each triangle. So we're going to find all 3 missing parts. And we start off pretty simple by finding the missing angle. So we can find angle C. So angle C, obviously we can take 39 plus 37. Oops, I wrote the same thing twice. 39 plus 37, and that is 76. And then we can do 180 minus 76 gives us 104. So angle C is 104 degrees. So nothing new there. We've done that many, many times. We found the missing angle if we know 2 of the angles. All right, now that we have 104, we can set up the law of sines. So we need side A, and this is called side A because it's across from angle A. And we also need side B, and it's called side B because it's across from angle B. And you just pick one that you want to find. Let's say we're going to find side A. So what we can do here is we can write A over the sine of A equals, and we have to use the two that we know. So we know angle C and side C. So we have to use those two. So we will put C over sine of C. So that's the main equation, and we're just using that proportion. We know 3 of those 4 things, so we plug them in. So we don't know side A. We know angle A, so sine of 37 equals, and that was angle 37. I notice there's 2 37s here, so I don't want to mix you up. So over sine of angle A, and then side C, which is 37 inches, over sine of C, and that's angle C, so that's 104 degrees. And now we have this. It's pretty easy to solve. We just have to find side A, and just using algebra, and we'll take care of the trig ratios in a minute, but we want to solve for A, so we just multiply both sides by sine of 37. Now, we could have found the sine of 37, found the sine of 104, and then done it that way, but it's actually easier and quicker to go ahead and multiply by the sine of 37. And really, what we can do here is we could now just plug it in our calculator. I'm going to rewrite this, which normally I wouldn't, but I want you to see it. So really, this is over 1. So we have 37 times the sine of 37 over the sine of 104. And we can enter this right into a calculator. What you want to do is make sure your calculator is in degrees. So I'm going to hit mode. Now mine looks a little different. Mode down here, you see it says angle, and ratings is selected, so I need to click degrees. And so now I have degrees, so that's good. I'm done. Whatever you need to do in your calculator to put it or make sure it's in degrees, you need to do that. And now we will find what this is equal to. This is this. So I'm just going to type in this equation here, or this expression. I'm going to type in 37 times the sine of 37. I'm going to have to close my parentheses here. And I could just put enter, or I can just hit divided by 104 because it will do sine of 104 because it will do the order of operations for me. Divided by sine of 104, and we hit enter, and we get that side A is 22.9, and this is in inches. So we found side A, and now we need to find side B. Well, here is side B, so that's our unknown. So we'll do B over the sine of B. And I usually like to just go back to the 2 that we found or had to start with. So I like to write 37, so side C. Actually, I wrote it with the formula, side C over sine of C. We'll plug in our values. We're trying to find B, so we'll leave that there. Sine of angle B is 39, equals side C, which is 37, over sine of C, which is sine of 104. Once again, we can just multiply both sides by the sine of 39. I didn't leave myself much room here, so sine of 39, sine of 39. This is going to be over 1. And so, again, I don't need to write this step, but I'm going to do this because we're early on. So it's going to be 37 over times the sine of 39 over the sine of 104. Now, our answer for side B is going to be very close to my answer for side A because 37 and 39 are pretty close. Side B will be a little bigger because its angle is bigger. So we can just type this in. We have 37 times the sine of 39 divided by the sine of 104, and we get 24. Just a bit larger than side A, so 24 inches. And so we solved this triangle. And that's it. So in that case, we were given two angles and an included side. In this one here, this next one, looks like we're giving two sides and a non-included angle. So this is side-side angle. And we are able to do this. I'm not giving you any of the special cases right now. So let's see what happens here. So we have two sides in the included angle. We can't go and find another angle right away because we only have one. We need two in order to find the other one. So in this case, we jump right into the law of sines. And since we know angle B and side B, we want to make sure we use those. And so we also know side A, which means what we can do first is find angle A. So we're going to find angle A first. And as I mentioned before, when we're looking for an angle, we actually put the trig, the sine of A, on top. So in number 2, we are going to use sine of angle A over side A equals sine of angle B over side B. And the reason we're using B and B is because we know those two. The reason we're using A is because we know side A. We can't use C and C because we still have two unknowns. We don't know either of those. So let's plug in. This is going to be sine of A over side A, which is 13. And that's going to equal sine of B, which angle B is 110, so sine of 110, over side B, which is 30. Notice here, to help us solve, we're going to go ahead and multiply both sides by 13, which over on the left, that cancels. So we are left with sine of A equals, and I'm actually going to put this 13 up front, so 13 times the sine of 110. And I'm going to put that in parentheses so we don't forget to do that, over 30. So we can put this in our calculator. 13 times the sine of 110, close the parentheses, divided by 30. And we get that the sine of A is equal to 0.4072. Now it's good to go to at least 4 decimal places, not 3 decimal places, and definitely not 2 or 1 decimal place because it will really throw off your answer. So we go to 4 decimal places. That should be accurate enough. In fact, I usually just leave the number in my calculator and go from there. Now, what we need to do here is we need to use inverse trig. So how do we get rid of sine? Well, we do inverse sine. And we did this before when we did trigonometry. So inverse sine. So on the left, the inverse sine and sine really just cancel each other out. And so we have A equals, on our calculators, we're going to do inverse sine. So I have to go second sine. And I'm just going to put the previous answer in on my calculator. What I have to do is I have to hit the second button here, and then the negative, so second answer down here. Close my parentheses, hit enter, and we get 24, really 0.0. And I'm going to put 0.0 to show that I went to 2 decimal places. So angle A is 24.0 degrees. Well, now that I know that, it's really easy for me to find angle C, and that is the next thing I have to do here. So angle C, well, to help us find angle C, we can add 110 plus 24. So angle A plus angle B is 134, and do 180 minus 134, and that gives us 46 degrees. And now that we know that angle, we're actually looking for side C. And so now that we're looking for a side again, we're going to look at this version of the law of sines because we're looking for a side. And in this case, we want side C. So I'm going to do C over sine of C equals, and now we really could use either B over sine of B or A over sine of A. I like to go back to these ones that I have highlighted because those were given to me. My 24.0 degrees was actually rounded. It wasn't exactly 24.0, it was 24.02902 or 7263. So I like to go back to the exact ones. So that I'm going to do B over sine of B. So that's the equation I'm going to use. I'm looking for side C, and I know the other parts. So sine of 46 degrees equals side B, which was 30, over sine of 110. I'm going to go ahead and multiply both sides by the sine of 46. And so what we have here is C. You can put this over 1 equals 30 times the sine of 46 all over the sine of 110. And we're going to plug that right into our calculator. And we get 30 times the sine of 46. Make sure you close the parentheses. Divided by sine of 110. And we get that side C is 22. Actually, if we're rounding to the nearest tenth, it ends up being 23.0. Now, a quick check. It's not an exact check, but at least it gives us an idea that we're at least on the right track. But we know from previous chapters that the smallest side is across from the smallest angle, and the largest side is across from the largest angle, which in this case, it all works out. If it didn't work out, we know we're wrong. If it does work out, it's just a hint that we're right. It's not a guarantee, but pretty sure we did all those right. So there is the law of sines.